We got multiplying monomials down. Let's get into dividing monomials now. A couple quick definitions are zero exponents and negative exponents. These are key to learning. They can cause a lot of trouble, but once you got them down, they're actually not too bad. Okay, so you just got to focus up when you go through these, and I think you'll be all right. So a zero exponent, it's just any non-zero raised to the 0 power. So basically anything raised to the 0 power. 3 to the 0, negative 5 to the 0, x to the 0, anything to the 0 power. Okay. Negative exponents, anything raised to a negative power. So 4 to the negative 2, x to the negative 5, just anything to the negative power. All right, and this has any non-zero number, because 0 to any power would be 0, right? If I took 0 to any power, it's going to be 0. So that's why they state that. Okay, let's take a look at how this is going to work out. I gave some powers here, 4 to the third, 4 to the second, so on and so forth. Let's take a look at what these all equal. I bet we can do the first couple together. 4 to the third, 4 times 4 times 4 gives us 64. 4 to the second gives us 16, and 4 to the first is just 4. Okay, before we can go over to 4 to the 0 power and 4 to the negatives, we need to take a look and see what is happening between the 64 and the 16 and the 16 and the 4. Well, if we take a look at it, it's basically the inverse of multiplying by 4 each time. We're really dividing by 4, aren't we? So to find out what 4 to the 0 power is, we got to take 4 divided by 4. Right, because 64 divided by 4 is 16. 16 divided by 4 is 4. And 4 divided by 4 gives us 1. Well, that's going to work for every case to the 0 power. So looking back up top here, 3 to the 0 power, that's going to equal 1. Negative 5 to the 0 power is going to equal 1. X to the 0 power is going to equal 1. Okay, anything to the 0 power is going to equal 1. It's a very easy rule once you get it down. Well, what about our negative exponents now? What's going to happen as I go to 4 to the negative first power? Well, that same pattern, isn't it? We really just divide by 4 each time. And I could write that as a fraction, right? 1 divided by 4, 1 divided by 4. So it looks like 4 to the negative first is going to be 1/4. Okay, same thing again. We're still just dividing by 4. Or essentially we're multiplying by the reciprocal, right? 1/4 divided by 4 is the same thing as 1/4 times the reciprocal, which is 1/4, to give us 1/16. So we have 1/16 here. And I bet you can take a guess that we're just multiplying the denominator by 4 each time to give us 1/64. Okay, we're going to show a little rule with that here in a sec. That'll save us some time, so we don't have to think through this. But this is why the zero exponents and the negative exponents work the way they do when we explain them here. So we take a look, we just talked about it, zero exponent property. Anything to the 0 power is 1. So 15 to the 0 power is 1. B over C to the 0 power is 1. And this big monomial here is simply just 1. So don't waste your time trying to go through and simplify that thing when anything to the 0 power is simply 1. The negative exponent, get a little more confusing, but not too bad. If you noticed back in our first slide, we had 4 to the negative 2 power, which we said was 1/16. Well, if you think about it, 16 is really 4 to the second, isn't it? So what I did was 4 to the negative 2, I just put 4 to the negative 2 down below and changed its negative to a positive and kept a 1 up top. That's where our rule comes into play right here. If you have something to the negative exponent, you're just putting it to the denominator and making it positive. Okay? Essentially, you really just put a to the negative n over 1, right? I can put any number over 1. And it just switches sides and becomes positive. Because if you look at my next example, a to the 1 over, we got 1 over negative a to the negative n. Well, to get it to be positive, I just move it to the top, and it becomes positive, as we can tell right here. Okay, so let's just look at a few examples. I bet the examples will make a lot more sense here. Oh yeah, so if we take a look, 2 to the negative 4. Really all that's happening is it's just moving to the bottom, isn't it, in my fraction, and becomes a positive exponent. So 2 to the 4th with the 1 on top. 1 over 2 to the 4th. Okay, it just changes sides of the fraction, right? And I can write anything as a fraction. So looking at my next case. Basically, if I have a negative exponent, move it to the other side of the fraction, and it becomes positive. So I have 8 to the negative 4th, or x to the negative 4th, I'm sorry. That's going to go move to the bottom and become positive. And then my z to the negative 6th will move up top, and that will become positive. And my y to the 9th just stays on top. So I got y to the 9th still on top, and I just move my z to the negative 6. Well, it becomes positive when I switch the sides, right? And x to the negative 4th becomes x to the 4th. Okay, that's kind of the simple way to think about it. You just got to think back to how it works. Let's go back to that first slide again. Just make sure, looking on the right side here, right? We just kept dividing by 4, and that's why it works out the way it does. It can be kind of confusing. You might just have to pause through this and go back and take your time. But the quick way is to make it a positive exponent, flip it to the other side, and it becomes positive. Okay, we have a couple rules here. Quotient of powers. It's the same thing as our product of powers. Remember when we had a product to the same base, we're able to just add their exponents? Well, with a quotient, it's basically just the opposite. I have the same base, and we're dividing, so now I can subtract their exponents. It's just the opposite. So if I look here, I can take each case individually. So I can work with my k's first, and then my m's, and then my p's. So k to the 7th over k to the 5th is really k to the 7 minus 5. M to the 10th over m to the 3rd is really m to the 10 minus 3. And a p over p, well, it's just p to the 1st for each one. So 1 minus 1 gives you a 0. That's just 1. They really just cancel with each other, don't they? That's another way to think of that when I'm multiplying in fractions. They can just cancel. So my final answer would be k to the 2nd, m to the 7th. K to the 2nd, m to the 7th. And we can talk about why that works here. Let's bring that. I'm just going to do a different example here. If I just said a to the 3rd, b to the 4th over a, b to the 2nd. I could rewrite that as a times a times a times b times b times b times b over a times b times b. Right? If I expand out my exponents. Well, they just cancel with each other if you got one on top and one on bottom, right? So the a's cancel, a b cancels with a b cancels with a b, and I can write it as a to the 2nd times b to the 2nd. Which would be what I'd get if I would just subtract their exponents. Okay? Let's take a look at the next one. X to the 7th over x to the 6th, so we subtract. So I get 7 minus 6. I'm just going to write this out. And y to the 3 minus 12. Notice how the top one comes first. I don't write 12 minus 3 because 12 is bigger. And I simplify that, and I would get x to the 1st. Don't need to write the 1. Y to the negative 9. Okay, here's the trick though. We never want to have a negative exponent. That's not the simplified form. So what happens? I can make this into a fraction, and that negative exponent can move to the bottom to become positive. So I can take this y to the negative 9th, move it to the bottom, and it becomes positive. So there's my answer. X over y to the 9th. Power of a quotient, same thing. We did power of a product, we just distributed. That's the same thing that's going to happen here. We're basically just distributing that m. So it'd be a to the m over b to the m. We'll just do one example here. Remember, I got a power of a quotient here, but I also got powers of products, don't I? So I got to distribute this third power to everything. So I got to take it 4 to the 3rd. I got to take x to the 3rd to the 3rd, all the way down here, 5 to the 3rd, and 5 to the 4th to the 3rd. I'm going to erase all that. I know it gets kind of confusing. So basically I'm taking everything to the third power. So I got 4 to the third, x to the third. Well, remember we multiply, right? We multiply when it's powered to a power, so x to the 9th, over 5 to the third, and y to the 4th to the third. Right, I got to send it down there too. So 4 times 3 gives us 12. And I should probably simplify my 4 to the third and 5 to the third. So I get 64x to the 9th over 125, y to the 12th. And if I could simplify my 64 and 125, I would, but I don't believe a number goes into both of those. So that would be my simplified form. All right, let's try one that kind of combines every single property we've used so far. So remember, it's a good idea to work with those negatives. Get rid of those negative exponents right away. Remember to get rid of them, you just move it to the other side of the fraction, they become positive. So basically I'm going to move this m to the 5th, negative 5th down low, that becomes positive. And I'll move these two up top and they'll become positive. And I'll rewrite this. So I have 75, p to the 3rd stays there. The m to the negative 5th dropped, but I have m to the negative 4 and r to the negative 8th that came up and they became positive. Okay. And down low, 15 stayed the same, p to the 5th stays, and the two negatives left, but my m to the negative 5th came down low to become m to the positive 5th, right? They just switch sides of the fraction and become positive. Okay, now we can go through, and I'll teach you a trick in this as well to save you some time. So I simplify my 75 over 15 first of all, and if you think, I know 5 goes into both, but 15 also goes into both, so we're going to divide both these by 15. 75 divided by 15 changes into 5, and 15 divided by 15 is 1, right? 15 goes into each of those. So far I know I'm going to have a 5 on top down here. Okay, here's my quick way to think of this. Instead of taking p to the 3rd over p to the 5 and having to subtract, I'll write that over here like p to the 3 minus 5, and then you bring back in negatives into play, it just gets confusing. If you think about it, I have p to the 3rd, so I got p times p times p, and then p to the 5th down below, right? P times itself 5 times. Well, 3 of these p's cancel with 3 of these p's. So think about how many p's you would have left. The 3 cancel with 3 down here, so I would basically have 2 of them left. So I got p to the 2nd down low, and those p to the 3rds canceled up top. Same thing with the m's. I got m to the 4th and m to the 5th. So 4 of the m's cancel with each other. So all 4 of those m's are gone. 4 of these m's are gone, so I'm just left with that 1 m, and that's still on bottom, right? And nothing cancels with the r to the 8th, so that's still up top. So this would be my simplified form right here. 5 r to the 8th over p squared times m. Now it gets kind of sloppy. You might want to go back through, pause, go through this slowly on how I went through those steps, and hopefully that'll make a little more sense to you. This will be our assignment for tomorrow in class. Come to class prepared, have some notes down, have your question ready to go, and I will be walking around and help you out tomorrow. Can't wait.